All right, these are the answers to our test review. For number 1, it says, what are the x and y intercepts for this? So for our x-intercept, we set y equal to 0. For our y-intercept, we set x equals 0. This is the probably quicker one to find, so we'll put 0 in for x, and we're going to get y equals 1 squared minus 9. And 1 times 1 is 1. 1 minus 9 gives us negative 8. So that's our y-intercept. Okay. As far as the x-intercept go, we're going to set the y equal to 0. And then we'll add 9 over. And what we're going to do next is take the square root. Now, in taking that square root, you have to consider both positive and negative square root of 9, because both positive or negative square root of 9 could square out to give us the 9. And if we subtract 1, we end up with this right here. So negative 1 plus 3 would give us 2. That's one of our options. Negative 1 minus 3 is negative 4. That's another option. So either one of those could have worked to give us those x-intercepts. Right. Number 2 says, consider the line that goes through these points. Can we find the distance and the midpoint? So as far as distance goes, remember the easiest way to do is to think of it, plot these points. So 2, 6 is like right there. Negative 6, 10 is like right there. And we're trying to find that distance. So think of it as a right triangle. So in terms of this side, we're going from 10 to 6. The distance between 10 and 6 is 4. That's that y side there. And in terms of the x, we're going from negative 6 to 2. From negative 6 to 2, that's a distance of 8. So the distance squared is equal to 4 squared plus 8 squared. So 16 plus 64, we get the distance squared equal to 80. So our distance is the square root of 80. All right? So you can leave it as square root of 80, or you can put it on your calculator, and it gives you 8.944. Roughly. All right. Either one of those is fine for our quiz, our test tomorrow. Now, as far as the midpoint goes, what we're going to do is look at what's halfway between these. So if you look at 2 and negative 6, maybe intuitively you know that negative 2 is halfway between them. If you weren't sure, the easiest thing to do is to add those together and divide by 2. So negative 4 divided by 2 gives us negative 2. Same thing for the y's. Halfway between 6 and 10 is 8. But if you needed to, you could have done 6 plus 10 divided by 2 and gotten 8 that way. Close that off. Find the slope-intercept form of the line that goes through these points. So in order to do that, I need the slope. So let's go y minus y over x minus x. We're going to get negative 4 over 8, which is a negative 1/2. All right, so there's our slope. And let's pick a point. I'll just pick the one that's all positives there, and we'll get y minus y equals slope times x minus x. Okay, so this is a perfectly good equation. They do want it in slope-intercept form, though, so we do have to distribute. Y minus 6 equals negative 1/2 x. Negative 1/2 times negative 2 is a positive 1. And then add the 6. And we end up with our equation, y equals negative 1/2 x plus 7. All right, so slope, then make the equation, and then work it out to get y by itself. What is the slope of a line that's perpendicular to that? Well, this slope was negative 1/2, so if we're perpendicular, we are opposite and reciprocal. So not negative but positive, and not 1/2, but we'd have a slope of positive 2. All right, second page gives us a bunch of functions here and then wants us to find some values. First one is g of negative 4. So we're going to put negative 4 into that g function. It's going to be negative 4 squared plus 4. Negative 4 times negative 4 is 16. 16 plus 4 gives us 20. H of negative 3. Now, since I'm using negative 3 and h is this piecewise, I have to look for the part that's less than negative 1. Negative 3 is less than negative 1. So I'm using this top part here. So negative 3 minus 4 would give me negative 7. F of x plus 4, I'm going to take x plus 4, I'm going to put that right into the f function. So instead of negative 5 times x, we're going to have negative 5 times x plus 4. All right? Now, this is legit. If you left it, actually, that would be right. But if we distribute, we get negative 5x minus 20 minus 2. And we end up with negative 5x minus 22. Right? f of g of h of 2. So we're going to start inside here, h of 2. 2 is bigger than -1, so we're going to use this part right here. So you're going to go -2 times 2 plus 3, which will give us -4 plus 3, and that's a -1. So h of 2 is -1. That's the first part. We're going to put -1 into the g function. So where this is, we're going to put a -1. That's -1 squared plus 4. -1 times -1 is 1. 1 plus 4 gives us 5. So now we're at 5. All right, we'll put that into the f function. So where you see x, we're going to put that 5 in. We're going to go -5 times 5 minus 2. -25 minus 2 gives us a -27. So we started inside, find that one, kind of block out those others. Find this, then plug that answer into here, then plug that answer into here. That's how we do it. All right, inverse of g, what we'll do on this one is we set g equal to y, and then we switch those. And then we subtract and then take the square root. So we get inverse g equals the square root of x minus 4. All right. If you thought about putting a plus or minus there, I wouldn't get too bent out of shape on that, but we'll just leave it there for us. Now, the other idea would be to say, well, g is a function where we square and then add 4, so I'm going to do the opposite. In the opposite order, I'm going to subtract 4 and then take the square root, and that's exactly what we have here. So either route works. And this one says if the function f equaled 17, what would x have to be? So we go back to our function f. All right, let's set that equal to 17. If you add 2, -5x equals 19, and then divide, we end up with x equal to -3.8 for that. All right, so not too bad on those. Next, they give us that piecewise function again. They want us to make it a graph of it. So if I look at the transition's happening at -1. So go to -1, and again, this isn't the graph, but it just helps us kind of frame the idea. For things less than -1, we're going to graph x minus 4. That's a graph that starts at -4 and goes up 1 over 1, right? So if I bring it backwards to here, and then kind of follow that slope down, here's a slope of 1, hits the graph at -5, -1 minus 4 would be -5, and then we have a transition. I am filling in the dot because it's equal to at that spot, so we're going to use that part for that. All right, for the other graph, this one starts at 3 and goes down 2 over 1, so if I bring that back, I get to this point right here, okay? But I'm going to open circle that because it's not technically equal at that spot. And we'll continue to use our slope of -2, so down 2 over 1, down 2 over 1, and run our line through there. And that's what that piecewise function looks like. One thing from -1 there, one thing for +1 there. Number 12 wants us to find the slope y-intercept. To do that, we're going to move our x over, so add 15x to both sides. We end up with that right there, and then divide by 9. So 15 divided by 9, you can leave it like that, or you can try to reduce it. It would reduce this to 5/3. I would not write it as a decimal, but 15/9 would be fine too. That's our slope, though it's in front of x, and our y-intercept is the other number. And what is our domain? Again, domain is everything we can equal. A better question to ask is what can't we equal? And the only thing we can't equal here is 0. That would create 0 on the bottom. That's a big no-no. So x can be anything it wants. It just cannot equal 0. All right. All right, then we get this graph here, and we're asked to find the domain and range and some other things. So as far as the domain goes, you see that we're going from -3 to 1. We're not including -3 because of the open circle, but we are including the 1. So in an interval notation, we're going -3 to 1. Don't include the -3, but do include the 1. Okay. For our range, we're going from -4 up to 0. It does touch on all of those things, even though that's an open circle. We do hit 0 right there. So we're going to go from -4 to 0, including everybody. Okay. When is this function increasing? We're increasing from -2 to 0. Okay, when is this function decreasing? We're decreasing from -3 to -2. And then we do again from 0 to 1. All right, when do we have a relative maximum? Maximum is when we hit that top, the top of the hill, and that's happening at x equals 0. And where do we have a relative minimum? That's where we're at the bottom of the hill, right? So that's at x equal -2. All right. Now, what is the average rate of change from -1 to 1? So at -1, the graph is right here. At +1, it's right there. So if we drew that line, we're really asking what is the slope of that line. Notice how that function went down 2 and over 4. Down 2 over 4 would give us a slope of -1/2. That's our average rate of change. How much did the function change? By how much did we go over? All right. Then we get to our last page. We're moving around. It says, can you list all the transformations? Notice we have a negative in front. That means we flip this graph. There's no negative there, no flip, but this one did. We see a -3 right on the x, so that means we moved right 3. And we see this +10 right there. That means we moved up 10. So keeping that in mind, like we have this graph here. This is normally the x squared graph. But we notice that normally the x squared graph opens up. This one's opening down, so this must have been flipped. It's also been moved 3 to the left. We're at -3, so that has to be a +3 inside that does that. And we've also been moved up 1, and so there's a +1 outside of that. This one gives us a composite function, wants to know what were the functions that created it. G of x is going to be our innermost function. So in this case, that 3x plus 4x is the inside. And what was that put inside of? It was put inside of x squared. When you put that in there, you create this graph right there. And then our last one wants us to write an equation for this. So it says the rate of a reaction. So we'll go R is jointly proportional. So we have this K constant that keeps things in balance. And because it's jointly, that means we're going to be multiplying by a couple things. One thing is the amount of the reactant, so A, and the square root of the time, so then square root of T. All right, so that would be our equation.